Okay, folks, we're at time. Good morning if you're local. Good afternoon, good evening, good night if you're not. This is the OpenPGP session. If you should be in some other room, well, actually, don't leave because we'd like to have we don't have too few people in the room. So my name is Stephen Farrell. I'm one of your co-chairs. DKG is the other one who's remote this time, and DKG I think is going to talk through the chair slides.
Excuse me. Thanks. So glad that everyone's here. We have a pretty straightforward agenda today, but let's start with the note well and the usual pieces here. So you probably already know the note well. If you haven't, please go back and read it. The slides are linked from the data tracker, and you can get more details there. This basically just says you need to know about the intellectual property requirements, and you need to behave yourself. If you are in person, we ask to make sure that you're signed in to MeetEcho. Probably the MeetEcho Lite client is the easiest one. It's also linked to from the data tracker agenda. Please join the queue if you plan to speak in the room. Just it's good for people who are remote to know who's speaking. And if you're and you should please don't use audio and video if you're in the room. We've had some strange feedback earlier this IETF from people who are listening in the room to the room. And if you're remote, keep audio and video off unless you're presenting. And if you got a headset, that would be great. Rich and Quan are both note takers. Thank you, both of you. Much appreciated. So one more reminder about how we hope to behave as a community. We want everyone to be pleasant to each other. Use argument about the topics, not about the people, and look for best solutions to the ecosystem as a whole. Yeah, I think we're actually doing a pretty good job with that, and I appreciate the working group holding to that. So the agenda we have for today, I'm going to give a brief overview of where the crypto refresh and the working group status is. I'll also mention this funny little widget that you see at the bottom left corner of the slides. We're going to have a discussion about the post-quantum cryptography draft, which will be Aaron Whistler. There's several subparts to that. And then we want to discuss some potential drafts for other adoption. That's if you look at our milestones, you'll see that this month we're expected to consider adopting 2 other drafts. And there's a handful of them that are up for discussion. Does anybody want to bash this agenda?
So not bashing the agenda, DKG, but I think the transition part is Justice was going to present that. Is that correct?
Yes. So Aaron will present the questions around the post-quantum draft, and Justus has some slides he wants to present about how we think about transitioning to the post-quantum future. There's also there are some slides for the second half of the agenda from Andrew Gallagher, who is unfortunately sick and can't present them, but I don't know, we can maybe do some PowerPoint karaoke with that if anybody wants to try to present them, or we can just take a quick spin through them about the replacement key work. But Andrew sends his regrets for not being here. So I'm not hearing any agenda bashing. I'm not seeing anything in the notes. So I think we will start with the working group status and crypto refresh. So since IETF 118, there was a draft 13, which just had minor cleanups being done to references and spelling and typos and IANA registrations and things like that. There's nothing substantive there. The draft is in the RFC editor's queue. I don't think we have anything else that we need to do on this right now. So please keep your eyes out for when this ends up in Auth 48. Those of you who are the authors of the draft, it's pretty exciting. We should be getting this to publication. Let's hope. I want to also mention, I'm going to go back to the beginning here. We got a badge for OpenPGP. So this is a badge that the IETF occasionally will produce badges for protocols. And the IETF asked a design group to come up with a badge for OpenPGP, and this is what we came up with. The nice thing about this badge, the green thing you can see there on the left of the slide, is that folks who are interested in identifying themselves as supporting the OpenPGP ecosystem can go ahead and include this in projects that you're working on. The badge, when I squint at this badge, what I see in it is a fountain pen, which is sort of signature reminder. There's also sort of a view of a padlock, for those of you who are into padlocks. And then there's also an identity, which covers, I think, sort of the main 3 parts of what OpenPGP offers. And so it's sort of a pleasing and visually distinct thing that we haven't seen before. So this is now available for your use. I haven't published the pieces that we have in a particular repository that make them visible yet, but I will do that shortly. And we hope to be making, I don't know, at least some stickers that we can hand out in person at the next IETF. Sorry that we didn't manage to get the stickers made in time for this one. This all kind of came together at the last minute. But yeah, if folks have ideas about where the badge might be useful, we'd be happy to hear some of those suggestions on the list. So the other big piece of working group status is that we are successfully rechartered, as you all probably know. The key point here is that we are working on specifications that provide guidance to OpenPGP implementations and applications. Our milestones are the PQC draft that we're working on. And then we have, in our milestones, we are expected to try to adopt drafts related to persistent symmetric keys and superseded keys sometime this month. That's the theory. As we all know, milestones are aspirational. Let's try to do them if we can. But if we decide as a working group that this is not what we want, that's also okay. We can adjust our milestones. I see in the notes, Aaron is asking whether we can pick our RFC number. I know of no way to pick the RFC number. I'm not sure exactly why folks think that 9760 is special. Maybe it's 4880 times 2. We can come up with some numerology that would make things happy. Aaron?
Because it was 2440, then 4880, and now we time to again.
I see. So that means that we're not allowed to revise it again until we get to RFC. Sorry, I can't do the math. I was going to make a joke, but I can't do the math fast enough.
Yeah, I mean, we can't revise the whole standard. We can add some bits and pieces, but we can't do a version 7 with everything new again. Sorry.
So I have noticed that the RFC editor does like funny numerology in their choice of RFC numbers, but I am more interested in getting the draft out. So whatever RFC number they give us, I personally am not going to complain about it, but I'm pretty sure that they're aware of this desire.
So if we remember, we can ask.
Yeah. Yeah. So that's a slide for the very end here. So I'm going to go ahead and switch slide decks, I believe, if I can figure out how to do that. But I think it's time, unless people have any questions, I think we should switch over to talk to Aaron's talk.
So I think there is also an IETF webpage that has these protocol badges as well. So I'm not sure if it's there or not. Not there yet. Okay, so we'll make sure it gets there.
Yep. But many thanks to Occupop and to Greg Wood for helping us get the badges ready. It's much appreciated. So I'm going to turn it over to Aaron now. Do you have control of the slides, Aaron, or do you want to next slide it?
I'm going to try. I can't control anything, but maybe if I can request to.
I see. I see the request. I don't know how to grant it. Aaron Whisker asked to share the slides. Maybe I ungrant. Maybe I unpresent, and now you present.
And how do I present?
You click the little slide icon in the bottom.
Yeah.
Yeah, but I can only ask the slides. I can't really.
Okay. Well, if we can't figure it out, I will present them again.
Oh, I found it. Yeah.
I hit a button.
There it is.
Thank you,
that was the magic button.
I don't know. I didn't have the button somehow, or I couldn't find it. Go on. Thanks.
So I'm here to talk about 3 things. Let me see if I can actually slide through them. Yeah, amazing. So we're going to start from key encapsulation, then we're going to move on to key derivation, and then the fun topic, the signatures. That's going to be most of the presentation. We're going to start first each of these topics with the original proposal we had. We're going to consider the feedback we gathered through the list, and then propose a revised proposal that still has to go through consensus, but it tries to reflect what we gather from the list.
So Aaron, can you pause at various points and ask for people to go to the mic, because there's probably about 2 or 3 places that would make sense, I guess.
Yes, absolutely. Yeah. So this was the original proposal that most of you might have already seen at some other IETF. We had, compatibly with the crypto refresh, we put all the possible various curves pretty much, and we added the requirement level as the crypto refresh. Well, the feedback was mostly positive for X25519 and X448. Most people wanted both of them, and one of them must. We had some voices for having only a single elliptic curve family and moving the NIST or brain pool to a separate document, or to remove them at all. We had a bit of support for NIST or brain pool curves, one even proposing them as should for compliance reasons. And finally, we have one voice for Untrue and McAleese as hybrids. So we're going to get very quickly to the other proposal, and here I'm also going to stop if anyone wants to make any comment about this. We will reduce the algorithms into the draft to X25519 and X448, X25519 as must and X448 as should. The brain pool curves are going to be separated onto another draft that is going to go for adoption on its own. And then we have a question for everyone, is basically, is there interest? Does anyone want to do or contribute with a NIST curve draft? Don't rush to the mic. Yeah.
So we don't have to be strict about people joining the queue, but it's a nice thing to do if you can,
Okay.
if you have the buttons.
Mike Ellsworth. Yes. I mean, me and my company don't implement PGP, but in the sense that this is going to be probably shared with LAMPS, yes, the NIST and FIP stuff is of interest.
So just to clarify, is that a yes, you would like to see somebody do it, or yes, I would love to do it myself?
The former.
Okay, I think yeah, that's fine.
I think it's a happy to review. I'm happy to review, and I'm happy to coordinate with parallel LAMPS drafts.
Yeah, that's just fine. Thank you, John.
Yeah, so John Gray from Entrust as well. I was going to say basically the same thing. Yeah, in our LAMPS draft, we have the NIST P curve, so I think for alignment there, that would make sense, and I'm happy to help as well. Thanks.
Great.
I'm Quinn Dang at NIST. I would be happy to co-author with somebody or some other people on that draft, if that is what the group wants to do.
Sure. Thank you. Okay, so it sounds like people are generally happy with the altered proposal. We'll basically wait and see, try and find people to write those drafts, and when they pop out, we'll bring them to the list and proceed as normal from there. I guess the only thing that leaves is the suggestions for what was it? What were the other algorithms people suggested? If you can go back a slide.
We had McAleese, and we had too far, and True. I mean, I would say this is a little bit also here. If anyone wants to propose a draft with this,
right. I mean, I think that if somebody wants to write a draft for that, then they can write a draft for that and propose it to the group, and we'll see if there's sufficient interest in those. Mike. Oh, sorry, we have Daniel first, Mike.
Yes, sorry, thanks. At the risk of being a bit contrarian, I would like to kind of question the need for having multiple different, non-PQ algorithms, because in my mind, these are purely a fallback, right? In case the post-quantum algorithm turns out to be insecure, then at least we haven't degraded security, right? But I don't particularly see a large need for having so many of them, especially if we say that the first one is a must implement, then people will have to implement X25519 anyway, right? And I mean, X25519 is pretty fast. I don't see sort of huge downsides to using that one. So again, I sort of question the need of having all of those options, if that makes sense.
Mike Ellsworth, I did not get in queue to answer Daniel's question, but I can. The argument that I've been making for why alternate classicals, I think I see your point, and I agree with your point where you're considering software implementations that are easy to patch. But I think if you consider, for example, decryption in a smart card, you may be hard pressed to find widely supported smart card vendors that do X519. So I think it's supporting the current generation of technology allows better bridging.
So smart cards and PGP is an area where I have vast ignorance, but I understand it's a differently tricky area compared to smart cards and SMIME, for example. So I mean, I guess these issues will be raised on the list as people write a draft that proposes P256 plus MLChem or something, and I guess we'll have to see what the working group consensus is when we have those drafts available. I mean, it's not like it's going to take a long time for somebody to write a draft, so we can basically discuss that issue on the list then, probably.
And Stephen, to make your point that you've made on me a bunch of times, I'm not a vendor of this technology. So I'm advocating for a thing that I don't sell. So it'd be nice if someone who actually made these technologies was here. The thing I actually got in queue for is at the risk of stepping into the flame war and admitting that I have not followed the mailing list discussion on this, no pure PQs is a firm decision here.
Nothing is a firm decision, but I don't think that was proposed.
I thought, at least for encryption, I think there is a general consensus for staying hybrid. This also matches the recommendation of the authors of Kyber that they also made as matches their lithium. And the price to pay in space and time is like in computation, and especially in extra bandwidth, is so tiny that I think it justifies the expense, at least from my point of view.
Thanks. Tero?
Because we are adding new stuff here, I would actually think that this is something that actually is not very easy to, if somebody encrypts, uses one of those keys and other one doesn't, they can't decrypt and that kind of thing. So I think it actually would be very useful to have a really big wide of, everybody implementing everything once, because I mean, most of those, if you are using Brainpool curve or if you are using NIST curve, it's actually usually very easy to add in software. So I mean, it's just adding a new group and say, okay, do about the same operations. So that I think actually it would be good thing to have a multiple groups that people would have. I really think that it's very important to have a one must and should you be algorithms that people should be using, but having extra ones there doesn't really make the implementation that much harder now. But if we add them later, and if we actually add them in multiple drafts or multiple RFCs, that actually makes out that, somebody actually picks this and somebody don't do that. That's why I was thinking about it might be actually better to have than one RFC. Because I mean, if somebody is implementing that RFC, they probably just put all the group numbers in because I mean, it's just a couple of numbers in the implementation.
So that's essentially the original proposal.
Yeah, I think it would be better to have, I mean, most of the implementers, they get an RFC and implement that. And if they get one RFC here, they get the first one, and they actually never ever know that the other ones, because the management didn't give them as a requirement. If all of them are in one RFC, they will implement all of them, because I mean, just adding the group numbers is not that hard.
Daniel?
So personally, as an implementer, I don't think there's a particularly big difference in, you know, how likely we are to implement it, if it's in one draft or in multiple. If it's both a may, either way, then I think. I mean, all of these curves are already in the crypto refresh, as Aaron said. So I think the implementation cost is indeed not that big. So I won't sort of say that I'm extremely strongly opposed, but I just question the need. That's all.
Sure. Scott?
Scott Flores is a system. Sorry, my data tracker is not working. I'd like to make a small correction to Taro. The differences between X25519 and P256 is more than just tweaking a few constants somewhere. They actually use different algorithms. Yes, as long as NIST and Bayesian pool are the same, unless you're using the NIST curve is actually using a specialized reduction modulator function, which is more efficient than a generalized one.
Okay, so we've had, I think, every possible suggestion so far.
Yes, I mean, when we considered another alternative to this proposal was actually the same with X25519, X448, and that one brain pool and one NIST curve. That would be most likely the 1024 bits like matching, because the idea would be you have also two curves for compliance without exploding the number of them. But if you need to go for compatibility with hardware devices or for NIST or brain pool compliance, you could just use that.
Mm-hmm.
So if people prefer that, that's also an option, in my opinion, on the table.
Okay, John?
Yeah, I was just going to say, so I've been working more in the LAMPS group, so we have similar proposals, right, for chem and signatures, and then we have all the combinations together in one draft, and you're having an altered proposal now that you're breaking them up into different drafts. So I guess I missed a bit of the context behind that. Is that just because you want an easier to digest, like smaller bits are more digestible by people, or is it just you're just proposing this now? I guess I'm just because we could do that in LAMPS too. If people like it more, if they like the smaller digestible bits and that's better and it helps, sure. Just
so
wondering
there
about
is
that.
so there was one topic on the list that is probably different here than in LAMPS, is that I think we're dealing with an 8-bit code point size. So
Okay.
we don't necessarily want to burn a whole bunch of code points if it turns out that one of these combinations turns out not to be attractive or is implemented wrong or whatever. So I think that's a slight difference here, and might be a reason to proceed with the the most first, get some interoperability experience with that, and then allocate code points for other ones later.
Okay, that makes sense. Thanks for that context.
There's also, I mean, this is more than the CAM, is also for the signatures. If you think about ECDSA versus EDDSA, if you keep just the first two, you save on a whole algorithm that is ECDSA. So you have a draft that focuses on EDDSA plus. But this, I don't want to speculate about signatures that are going to come later.
Yeah, and I mean, I guess to Taro's point, even if we start with multiple drafts, if we have a clear working group consensus on the menu of things we want, we can merge drafts later. Just because we start with the NIST curves or something, or brain pool in separate drafts, doesn't mean that text couldn't be all merged into one at the end. Whereas I suspect it might help us to have a draft which maybe just has the must code point, get some implementation experience with that, and proceed with the others as we go, and then we don't burn so many code points. DKG?
Yeah, I just wanted to flag one additional piece of context that I think John might also not be aware of for OpenPGP, which is that given that we have this narrow registry, most of the code point allocation needs to be done delicately. And there is a range that are private and experimental, which we are starting with. And when we had everything piled into one draft, we ran into a situation where the private and experimental range was actually smaller than the number of algorithms listed here. And so even if you wanted to try to do them all and demonstrate them, you couldn't do it in the experimental range. So you sort of would be blocked waiting on some sort of IANA pre-allocation. So that's another little wrinkle that is OpenPGP specific that would not have played into effect in LAMPS.
Okay, oh, John?
Yeah, great. Thanks. I was just going to say thanks for that background history. Thanks.
So to summarize, yeah, I guess there's, every algorithm combination has its fans. I think the altered proposal here is to, get some implementation experience with the top two, the must and the should. Hopefully people will propose drafts for Brainpool, NIST, and even N2 if they want. We'll discuss those drafts on the list, and maybe at some point in the future, the ones that kind of survive the level or have an ongoing level of interest might all be merged into one RFC at the end. That sounds like what people are. Does that sound like, or does that sound wrong? If somebody wants to correct me and say I'm getting it wrong, Stavros.
Yes, hi, good morning. So, Stephen, please keep in mind that, now we have a draft that is reflecting all those choices and somehow addresses different needs and compliance requirements, maybe, like the CFRG curves, the Brainpool curves, the NIST curves. If we go to split, this takes time. And, we split a working draft, I think. Aaron, Johannes, Falco, and me, we worked quite a little to get this draft into a good fashion, and being readable, being concise, being correct. If we split, this takes time and effort to split basically ECDH from the X curves and the Edward stuff from the ECDA stuff. If we merge it again at the end, it again will take time to get it into a concise, readable fashion, not just concatenating stuff. So I would rather wish for some kind of a decision to say that let's keep it together as it is right now, or split it and just do it that way. Yeah. As John said, digest it in smaller bits. That was just my concern at that point.
Sure, understood. Yeah, I guess if in a nearish future we have multiple drafts, it's up to the working group to figure out if we want those merged or not. Yeah, I think that's something we can discuss as well. I wouldn't worry too much about the editorial overhead, because I think the text in these things is pretty much similar. So
okay.
Hopefully that's not too bad.
To express my thoughts here. Thanks.
Understood. Mike?
Mike Ounsworth. I think I vote split. I think I vote split on the argument that the X curves is the one thing we all agree on, and therefore we can move fast with it and get real data in the wild protected on the sort of common case quickly and not have it slow down with all the debate over the other stuff.
Thanks. Ken?
Queen Dang again at this. Potentially, if we decided to split, and we are going to work on a draft for the NIST curve, and if I were one to be co-authors, I probably would suggest to add MLChem 512 as well. And then we would talk about it at that point.
Okay, so that sounds to me like another justification for splitting this.
Yes.
Yeah. Okay. All right. So with Stavros' let's keep in mind we don't want to make the editors do make work. It sounds like this is a way forward for the next while anyway. Cool. And then we come to the next wrinkle, which is, I guess, back to you, Aaron.
Yeah. So this is just what I said. Key derivation and combination, and basically same game. We started with the original proposal where we had only the algorithm ideas, fixed information, because everything else was coded into the KMAC like in the domain separation and customization string. We use SHA-3 256 and a Kramer-Shoup construction to derive a key from a key share from ECC. And then we use, we just take this key share, concatenate with ciphertext, and same for MLChem. And at the end, we just run everything through KMAC. The feedback we got from the list was not too much. Only a few people replied to this thread. And basically, they said, don't specify an OpenPGP custom CAM combiner. Try to use something that also other protocols might want to do. Include the public keys into the CAM combiner, even though the paper that we're based on does not require, for the security proof, the public keys. And reuse an existing key duration function for ECC, so don't invent your own. And KMAC seems to be fine. Here I'll say a name, Justice open an issue, and he was like, he also found a way, like he originally had found trouble to implement it. Now he seems to have solved it, but there's still the question of what are the advantages compared to SHA-3. Quinn, if you want to, I think we can also.
You're in the queue.
Yeah, exactly.
Okay, yeah. So yeah, Aaron, you get to the next slide or so, and we'll.
Okay.
No, let him get to this one first.
Okay, so this is the altered proposal. As before, this still needs to go through the working group, but this is basically based on the feedback we got. And we kept the same ECC key share derivation system because this is exactly the same that is used for X25519 or X448 in the current crypto refresh, just with SHA-3 instead of using HKDF. And the reason is that we already use SHA-3 elsewhere in the post-quantum draft, and we thought that was consistent. Then we moved the domain separation to the fixed info, and yes, ECC-CT is there twice, Mike. And the reason is that the fact that the first time is it into the key share when we do the step of deriving the ECC key share. And once we concatenate it, in order to retain in the END CCA2 security into our CAM combiner, we put it a second time. And basically the idea is the fact that MLChem data also adds the public key. And then we just use SHA-3 256 instead of using KMAC. The reason is we always have a fixed length output, at least with the current draft, of 256 bits. And we originally excluded this SHA-3 because it might have a collision if you squint hard enough with the ECDH key combiner, key derivation function, but it is so unlikely that I think it is just easier and simpler to use SHA-3 here. The security proof is not altered. Quinn?
Next slide.
You're in the queue. Okay, I think the next slide is just this, what I just said.
Yeah.
Great. Okay, so in case if you want to speak, is now your time to scream at us for this proposal.
Yes.
Quinn Dang, and this again. So I just saw a question. I just responded. It's nothing screaming here. So you asked whether or not the KMAC and the SHA-3. For KMAC, likely, if you care about FIPS validation, then probably the way we use KMAC here would be compliant with our standards right now. But if you use SHA-3, then it's not a sure thing for now. Because SHA-3 as hash function, we only allow that to be in 56C, where you can derive the share secret directly from your, we consider the key exchange and the KDF as one box. And the SHA-3 or the hash function is inside that box. And right now here, we're using SHA-3 outside the box. And we don't have that currently approved, but we have received some comments about this. People wanted to allow this way. And I don't know whether or not we want to do it for sure. I don't really know. But for right now, if we use KMAC to do this, then it's complying with our FIPS validation requirements, if somebody cares.
Okay. I mean, as far as understood, FIPS SP856C is what we would use for key derivation. And this counter is also initiated with 0001 as the specification requires. And then we would basically have ECC data and MLCAM data being the shared secret, and followed by the fixed info. So from my ignorant interpretation, this would be compliant with this standard. I do not know about any upcoming, key combination standard or anything like that.
Oh, we don't have any official key combiner or anything like that right now, so I can't comment on that. Yeah, so it just, that was it. So if KMAC, then likely we be complying with FIPS, but with SHA-3, then not sure.
Okay.
But in terms of security, they both equivalent. Yeah.
I shouldn't be taking notes. I think this is already a note taker. Yeah. If anyone has any more comments, please, come to the queue.
Yep.
Because we still have many slides to go. This is like 10 out of 30.
So on the combiners, though, I mean, I guess the altered proposal here is still an OpenPGP specific way of doing this, and I guess we want.
I mean, LAMPS is doing the same in the drafts that there are out there right now. So, and the CFRG, oh yeah, I forgot to mention the CF, there is a huge discussion going on in the CFRG in case you haven't seen it. And we're going to keep on following that one. So it's not that we're going to ignore what's coming out of CFRG. The only thing is the fact that it should try to come out briefly, and I don't think we should wait forever until the CFRG comes up with an idea.
Justice?
So I posted that to the list. I want to reiterate my point from an implementer's perspective. It would be nice to get one key combiner and not one key combiner specific for the post-quantum algorithm. And I feel like if we split the draft into 3, the likelihood of one of the drafts going off with the custom combiner will increase.
Okay, so you're saying that for all the CAM combinations for OpenPGP, we would desire a single way of doing the combination, single combiner, for all of the various options that we have for combining CAMs in PGP, which I think makes sense. Now that still leaves the question: is it desirable or to have that combiner be the same as something used in for CMS or etc. So so that's, I think that's still a question. I think what Justice said is probably quite, I imagine we have consensus on. We don't want different combiners for the different menu options in PGP. I'm guessing that that would get consensus. Then the next question then is, should the PGP combiner be the same as used for other protocols? And to what extent do we want to wait for that to happen, or try and move ahead, and so on? So,
Mike Unsworth. Yeah, so Stephen just said what I was going to say. I table a motion here that we put a footnote on this whole thing saying don't look too closely. This will get aligned when the CFRG thing is done, and then we move on.
So that's an optimistic view of CFRG's progress, which is fine. But nonetheless, I mean, it creates the possibility that people end up getting some interoperability experience with something that turns out to change when CFRG eventually produces a result. Perhaps there's other possible futures, but I don't know how happy or unhappy people are with that. John?
Yeah, so I was just going to say, as someone that implements this stuff as well, and you see what people are doing in the world, right? Like I could easily see someone using, OpenPGP, and then they, take the structures, and then they're using it with CMS or using it with other stuff. And then if you're using different combiners underneath, things are going to break, and then people are going to be confused. And if it's possible to have a single combiner that could be used, I mean, if it's possible, if there could be a security proof or whatever to verify that, okay, this is good. Or, I mean, even if it has extra overhead involved with it, I know, so there's some groups that, they talk about, they want things to be super efficient, but even if there's a little less efficiency and it can make everyone work together, I still think that's better in the end. Otherwise, it's just going to be a free for all for everyone. So.
Good.
Quindaganist again. I just look at the construction, and it meets our requirement for current for the drive keys from two CAMs, one CAM and one ECC, or two key changes. So that SHA-3 function there currently meets our requirements. Yeah, because right now we require only one of them to be NIST approved.
Okay.
So in this case, you can pick either one.
Okay.
This is currently missing 56C as well. And the KMAC is meeting 108.
Okay.
So just to clarify, yeah, because I need to look at that, and then it's fine because we use a counter there. It's okay. Counter is right now optional. You don't have to use counter if you don't need to.
Oh, good to know. I didn't notice that. Thank you.
Yeah, no problem.
Okay, so nobody seems terribly unhappy with the altered proposal.
Yeah.
We, again, this will have to be confirmed on the list and all sorts, but it looks like a way ahead for, at least for interoperability testing in the near term, with the, doing that in the knowledge that if CFRG produces a result, or if for other reasons we want to do the same as other working groups, some change might happen in future. Quinn, go ahead.
So between KMAC and SHA-3 256, so the KMAC, it requires at a minimum 2 permutations. You execute permutation 2 times because you take the key first, 1 permutation, and then you do additional at least 1 permutation to really produce any outputs. But SHA-3, you do only one. If the input is short enough, fit into one input of the permutation, then it's just one execution of the permutation. However, for SHA-3 256, the capacity is 512. But if you use KMAC 128, then the capacity only 256. So it's not sure which one is better in performance. So it's might be equivalent, but more likely most of the time the SHA-3 here would if everything fits into one permutation, then the SHA-3 is better in performance.
We were considering KMAC to 156. And
but the problem is the ciphertext, so MLCAM is big.
Exactly.
Yeah, so
that's the other thing, that we
Yeah.
have a huge ciphertext here, and also like the public key here is not tiny either. So
but
like-
that means if we do with KMAC 128, it's limited to only 120 bits of security. So that's another matter. So if we want higher security, then we have to go with the but the same thing with SHA-3 to 56, only limited to only 128 bit of security. But if you want, hopefully you want a little bit better, like maybe, no, SHA-3 512 is a little too much. Yeah.
Okay.
Yeah.
So
Also-
are we? Yeah, go ahead, Aaron.
So it looks
also-
like KMAC 128 is better in performance.
Yeah, I mean, as Daniel is pointing out on the list, DKG is the fact, not on the list, on the chat, is the fact that the expensive part here is definitely not the KDF, is everything.
Yeah,
else
again,
that
I'm
we
not
need
too
to
sure
go
because I
through.
have to. The 768 is how large is the ciphertext? I don't remember. Is yeah.
Okay.
Okay, should I go on with the signatures?
And almost. Okay. So. Okay, just to summarize then for the note takers, including yourself, this altered proposal, people seem happy with it, at least as a basis for interoperability testing, with the knowledge that we might decide to change it again if there's a combiner that's used across more than just OpenPGP. I think that's the summary.
Yeah.
Great. Okay, on to the fun bit.
Digital signatures. So this was the original proposal, and where also SLH-DSA was split into 6 different parameters from 128F to 256S, so that it has an internal parameterization. Now, we have something like 100+ messages thread on the mailing list. I tried to summarize it in the next 14-ish slides, and I tried to make sure that we basically lay out 3 different solutions for which each one we're gonna have to look at what changes do they imply on the protocol level, so to OpenPGP. How can we achieve backwards compatibility with v4 or with non-PQ, and which security guarantees do they provide? And for each solution, we're going to go through the positive and the negative feedback specific to that solution that was expressed on the list. Finally, we're going to have some generic feedback about signatures and post-quantum signatures. So if I misinterpret anyone's opinion on the list, please say it, stop me, bash me, scream at me. And I tried to summarize these solutions as well as the best I could. I also asked for some help to our chairs that happily provided us with a review of these solutions. Let's say it like this.
And so I guess
from-
just to add, Aaron, I think on this topic, I'd be surprised if we immediately reached consensus today. So I think teasing out these arguments, it may end up being followed up by some interim meetings where we actually try and reach consensus on some decisions. So I think today, we're more in the teasing out of the arguments place of the discussion, and not necessarily on the fighting for the actual answer part. So I think, as we're discussing this, I think Aaron is kind of presenting pros and cons. We're gathering input, we're listening to arguments, and it may take some more interim meetings before we start to reach decisions. So with that, thanks. Go ahead.
So basically, this is the solution. Option 1 is also called migration-like ECC, and it's very much the most straightforward solution you can imagine. We add 2 different code points, one from MLDSA 65, one for MLDSA 87. And as much as it happened with ECC, people over time will generate new keys, deprecate the old keys, and just like if you want a transition period, you just sign a message twice, once with ECC, once with PQ. There is no non-separability guarantee. All the signatures where they can be doubled up, they will be doubled up, and it's up to the verifier to choose whether to accept a PQ signature, whether to accept it as standalone, or whether to require any set of any set of requirements lies on the verifying end. So this is the feedback we got in favor of option 1. And well, first of all, it is the most straightforward approach. So it is the one that introduces least complexity, at least on the signer side, or on the protocol level. The ECC migration was done this way. Basically, if we survive through the ECC migration, why shouldn't we survive this other PQ migration? Furthermore, signatures are to be considered valid at the time they were created. Clearly, the signature creation time is into the signature itself, so it's a bit self-referential. But you might want to authorize a signature so that you can prove it was emitted at a certain time before a quantum computer existed, or so, or before an algorithm was declared broken. And another solution we got on the list was to define these post-quantum signature code points now, but not actually recommend using them. So wait till we're more confident about them. And this solution can also be used with nested signatures. So in OpenPGP, you can put a message, sign it, and then sign the message with the signature itself. We have seen yesterday evening, I think in your time zone, we have seen at PQIP that this does not guarantee non-separability, but only somehow in one direction. And this shifts the responsibility onto application layers, and this gives greater flexibility to the protocol, makes it more agile, so that tomorrow we can also remove the ECC signature without breaking anything. There is also some feedback on the list against this option, and mostly the fact that some application layer do not handle multiple signatures properly. Some PGP MIME application layer will choke on them. Some will just consider the first signature. Some other type of signatures will not work when doubled up. So this is basically all the binding signatures into a key, for instance, or this, the direct key signature. The author Dilithium recommend using this algorithm in a hybrid fashion, and this scheme, at least in my opinion, does not provide a framework for always having a hybrid fashion. So sure, you can emit a hybrid signature, but you're also very much free to just emit a pure dilithium signature without any other, ECC signature attached to it. And signatures may convey different information. This means that the metadata of the signature creation time or expiration, or like all the stuff that is into the subpackets of a signature might just be slightly different, and it might make different to match two signatures together. So like one might be expired while the other might not. And then clearly separability might make look like someone is not able to produce a PQ signature, or like a stripping attack is undetectable from someone not wanting to emit a signature. A little bit more of feedback. We got the fact that shifting the responsibility onto applications, for instance, mail user agents, will cause interoperability issues and confusion. Basically, I send an email to a Proton user and a Thunderbird user, and they have two different verification statuses. One verifies, the other doesn't, because one accepts post-quantum signatures and requires them to be with Yeah, Daniel says that's also the layer above the application layer, but I mean, a mail user agent might just interpret these things differently. When we have two signatures, we, as of now, assume that it's an OR, but we don't really know because there's not really a lot of literature whether this should be an AND or an OR behavior. And the fact that systems might take some time to update might make us want to design an AND mechanism. The thing is that this AND mechanism might not be consistent across applications, as also the previous point. And then it will require two certificates for security purposes. So even in an environment where I know that everyone speaks PQC, so I send an email to my friends that I all know that they have PQC keys, I will still need to sign my message with a classical key in case I want to protect it against, PQ compromise, PQ algorithm compromise. And I cannot, even within homogeneous environments, there's not an option to just sign PQ. And then nested signature are, at least in my opinion, very, very difficult to get running. So, I mean, there are places where they don't simply work. Detached self-signatures in OpenPGP, we simply refused it, like we just choke on them. So I do not know exactly what's the support. I haven't found a test in Sequoia for this. And the fact that there is not even a test makes me think that probably is not a really requested feature as of now. I went too far. That was it. Should I stop now or should I present all three options?
I guess keep going, I would think.
Okay. My preferred option is to keep it going. Yeah. Okay, so we have the second option that is the composable hybrid. That is option 1. So we standardize 2 new code points, but we also additionally have a mechanism to bind 2 signatures together. If like CMS, if you say in signature 1, look also at signature 2. If you don't find signature 2, you will declare this as an invalid signature. This makes non-separability optional because this means that a signer may choose whether the signatures are to be looked at together or separate, but it provides a way to do non-separability. Now, we got only negative feedback on the list, so I will skip the slide about the positive feedback about this option. And mostly the fact that will create cross-layer dependencies and more complexity, especially from the point of view where you have where you start putting them into key binding or self-signatures into certificates, and then you need to read 2 certificates at the same time in order to make sure that they are they're valid independently. And there's also a little bit of a chicken and egg problem because which one you start looking at first when you have 2 of them referencing each other. And then there's the point of like 1 signature should be enough to validate bad signature, no signature. I do not know whether I interpreted this completely correct. Please stop me if I haven't. Option 3, composite hybrid. This means we standardize 2 to 6 code points with MLDSA and ECDSA or EDDSA in a PQT, hybrid fashion where both signatures are like we sign the material with both algorithms and the signature contains the key material for everything. Looking at the migration strategy, this means that we still have to do the V4, V6 migration or the V6 to PQ migration. This means that a user still needs to have probably for the upcoming future 2 certificates, most likely 1 V4 and 1 V6. And most likely they will still need to sign twice their emails or the software that they're signing or whatever they want to do. So we will need to find solutions to add 2 signatures in most places. But this solution clearly includes non-separability, and non-separability also on the key level. So a PQT key will contain both an ECC and a post-quantum signature at the same time. The non-separability is guaranteed by the fact that if you take within the post-quantum signature, you cannot separate the components. They sign also the algorithm ID, so you can't just take the ECC out and say this is the ECC signature. On the other hand, when you have 2 signatures, one v4 and one v6 post-quantum, then you can strip the v6 post-quantum, and that there's no separability there is not guaranteed. So back to the feedback. We have multiple voices that expressed that like the idea of having key binding or self-signatures that are hybrid, because this makes the key parsing, let's say, creates a binding within the key parsing. And some opinions about the fact that the hybrid signature reduce operational complexity because the operational security is harder than the protocol security. This means the fact that making sure that all your software is completely up to date, and it's harder than defining this at the protocol level. Or other people stated the fact that it shouldn't at least introduce additional complexity, because all of this is handled at the library level and not at the and the application is agnostic to the fact that there's an ECC signature in there. Someone pointed out that the backwards compatibility transition and the trust transition are 2 different, and while it is attractive to put them together, you're overloading the 2 concepts. Basically, you're making them one transition, and this one transition, the user might not be aware that this is a security requirement rather than just a backwards compatibility requirement. Also, the crypto refresh does not address the transition. The authentication protocols, so I know that no one is actually using SSH over OpenPGP. I tried to set it up, I gave up halfway through, so probably this is a sign that no one should be doing it. But they take only 1 signature, so there's no way to put 2 signatures there. The people who implement libraries, such as Justice, Daniel, I, or Falco, no one has expressed issues with the complexity that is hidden into the library level or is baked in. And then we have the fact that we can still, in the future, standardize standalone algorithms as we gain confidence into them. We tried to make a compromise where we do them both now. I think was ill-fated even from my side, because I think it's not a good idea to standardize everything right now. But I think that there is still an option tomorrow to do so. And then allowing mixing standalone algorithms with an AND policy. So basically, option 1 with an AND policy will just lead to application layers inventing some combination scheme and everyone doing something different and not having a coherent way to determine whether the verifier will actually verify my message. And I will have to keep on signing with ECC forever, because there might be some old clients out there that still require ECC. Some feedback against option 3 as well. So it is more complex to implement because we need to bake in the ECC complexity twice, one for each migration, one for the trust migration, one for the backwards compatibility migration. And point 2, if we support the non-composite post-quantum signature and a classic signature, we already have to understand how to put 2 signatures, how to tackle them, which one to accept, which one to verify, what's the policy. And so once we have figured all of these out, why not just use a single signature? Hybrid offers value only at the end of this transition period where we the backwards compatibility period, because if we don't when we're still signing with both keys in what I would have referred to before as non-homogeneous environment, where we don't know what the verifier will use to verify, we still need to sign with both. So the hybrid algorithms only start offering real advantages then, according to some people in the mailing list. And then once we have a CRQC, like a cryptographic relevant quantum computer, we have just unnecessary overhead. So we have the ECC stuff that is there for nothing, effectively. And then the signature validation policy, someone stated that it should be up to the consumer. This means the fact that it's not the signer who chooses how the consumer should consume, how to validate, but the other way around. We have one contradictory opinion instead, that the hybrid signatures increase the operational complexity, because if you get a single key compromised, this is fatal. Instead, the other one, you need to have two keys compromised in order to and they might be stored into different hardware tokens, for instance. And then there's the risk of also talking about hardware tokens, that they might reuse the same private key material for the ECC part of it, because they already have a HSM with the ECC stuff in it, and they just make a signature with ECC legacy with the same key as the post-quantum PQT algorithm. Here is not a problem, because anyway in the signature there is an algorithm ID, so it's not a security problem. But if the key gets compromised, then you got to remember to revoke all the keys, not just the matching key if you reuse the key material. And then there is the risk of algorithm code point explosion, because if you need to have one key point per each combination, if you start making 6 of them, well, then you got 6 already. We got some other feedback that I couldn't classify whether it was positive or negative, but it was feedback. So we have the fact that hybrid signatures should be named differently from the standalone ones in case we do them, because then if tomorrow we need to standardize the standalone, it should be different. There was one voice for limiting it only to one algorithm for experimental purposes, see where does it go and how does it work. There was someone else who tried to offer a drink and have 2 algorithms instead. This is a new negotiation technique. I might offer 2 drinks instead if we do 3 code points. And then instead we have one voice for having the algorithm parameterized. This means the fact that we have one single code point, but then we parameterize it into, this is the OID of the curve, and this is instead the MLChem, the MLDSA specification. And then we have instead multiple voices for the very opposite, that is, don't use parameterization. In fact, given the strength of the non-parameterization, we decided to completely remove it. MLDSA specific feedback, most people support both ML65 and 87, as some say either or, but with 87 preferred. And going to the slightly forgotten SLH-DSA that instead was proposed already as standalone, we have one voice to keep it most with one of the variants, so either SHA-2 or SHA-3, and with 1 or 2 parameters at most. We have one voice onto must, that it should be also a must, and one voice to have it hybrid with curves, because the same arguments that apply to MLDSA also should apply to SLH-DSA. Some more contradictory or mixed feedback from the list. We have that signature generation and verification may be at distant point in time, so to consider this when designing the algorithm. We have that at least 2 different security assumptions should be at must level, so one SLH-DSA and one ML-DSA, for instance. Then also don't create a combinatorial zoo of algorithm, but at the same time, make it easy to introduce new algorithms. And I don't know how to tackle this, but probably the first one means don't make 15 code points right now, but make sure that they can be expanded later. Don't reduce security along the way. This means pick higher security levels. And someone said it is too early to start issuing PQC signatures. Someone else said we need them now for the CNSA 2.0 requirements. But these also mean that different environments might have different transition speeds or periods. Like code signing might be different from email signing in this very case. And then, generally speaking, there seems to be a consensus that practical attacks against post-quantum computer may arise earlier than a CRQC. So PQC might be broken in the next years. A CRQC might come up in 10, 15 years. So this seems to be the window. So we get to the altered proposal. We included only 2 hybrid algorithms with 65 and 87, with ED25019 and ED448. This mirrors exactly the CAM side. We discussed very long, actually a little bit, between the authors which of the 2 SLH would be great to have, and we got to 3. The reason is the 128F is the only one that can be used as a backup in case ML DSA is broken. So it's the only one that has similar signature times or like similar properties that allows us to basically use it as much as it was ML DSA-ish. All the others are way too slow to do so. While instead code signing might desire 128S or 256S because they just have enough time to sign code, even if it takes 2-3 seconds, that's fine. At the same time, they prefer compactness, so we provide one low and one high security for that use. PQC brainpool is also gonna be moved to a separate draft, as much as at the CAN side. And we have the same question: is does anyone want to do the NIST curves? And yeah, the queue is open. Please. I stole the chair's job. Yeah.
Yeah. So I would be willing to co-author with someone or the people on the last item question there.
Mm-hmm. Thank you.
No. Mike Ellsworth, I made the mistake of sitting in the corner. For those not on the Jabber, there's a pretty healthy, robust discussion going there that's worth reading. And I want to point out that I asked this SLH DSA question on the LAMPS list in March of 2023. And I tried to base it on the argument there could be implementation bugs, there could be CVEs, protection against new code. And that got like thoroughly rejected. So it would be, I put the link in chat to the mail list archive. So it'd be weird for PGP to make a different decision, I think.
Stavros?
Yes, so this is another reply to Mike's question or aspect. I just wanted to ask the group what they prefer. So here's again the question of splitting. From the BSI's point of view, because we are using the brainpool curves as our interoperability parameters in the German public administration, we are obviously in favor of this to push forward the brainpool stuff. But of course, from an algorithmic perspective, it would make sense to not just define the brainpool curves, but also the NIST curves in the split. Yeah, because it's again using ECDSA, and for us, it's just another code point, and the test vectors, of course, for the NIST curves. So what would you prefer for my, as a question from my side, to have 3 drafts or one that focuses on the Edwards stuff and SLHDSA and one that defines ECDSA with some further curves, let's say Brainpool and then NIST. And the same for the camps, right? So that would make the ecosystem maybe a little bit easier. Just a question from my side.
Sure. And I mean, I guess if a bunch of document authors get together and do that, then that would seem fine. Yeah. So yeah. So if the people interested in writing Brainpool drafts and NIST drafts get together and write a Brainpool plus NIST draft for either CAMs or signatures, or combining all those, that seems reasonable. So, Aaron, are you in the queue to talk to yourself, or?
I have a question for everyone who wrote into the Zulip. I have, like, if anything is still open, because I see many questions and also many replies, please bring them up now. I can't really follow the discussion while presenting, sorry.
Sure. John?
So, yeah, so I was just going to say in our LAMPS draft, we have 13 combinations. So basically we've done the kind of monolithical route. So we have the brain pools, the NIST, and we also have the MLDSA 44s. And I mean, that came about because we had so many people wanting that, right? So we've had, I don't know how many conversations over the past, I think close to 5 years. And we settled, like, we tried to make the list as small as possible, but I mean, it's, different jurisdictions like different things. And so it's hard to, I guess, get people around the world to agree on a small set. So I guess I'm just trying to say that, I mean, you could do it that way too. I know you mentioned you have limited code points, so perhaps that's a consideration here and why you need to do it differently. But I guess we should probably, I know we've talked to you, I mean, Aaron and PGP people in the past, that we want to make sure that our stuff kind of aligns as much as possible. And I think, I mean, it's showing that one thing on this chart here, you have the SLA HDSAs. We had removed that about a year ago, based on, Mike had mentioned at the mic just a few minutes ago. We did originally have it, but then it seems like people think or trust those ones enough to be on their own. So we've removed those. Perhaps those aren't needed here as well. I mean, if they're needed here, then I would say they're probably needed elsewhere. So if it's decided in one area it's not needed, it's probably similar to another. So I guess just trying to stay aligned on that. And again, a lot of us use crypto libraries, right? That, I might have a crypto library that I write, but maybe I'm using it for PGP, but I might also use it for CMS. And the more we're aligned, the easier it will be for the crypto implementers. Thanks.
Excuse me, if I may answer quickly to you, John, is the fact that SLHDSA is not composite, is standalone. As much as I think also in LAMPS there's a draft for standalone SLHDSA.
Oh, sorry. Is it? Sorry, I'm. It's late here. I was thinking
late. Don't worry, it's so fine.
Sorry, I just thought there was a plus in there. Sorry, I see that now. Sorry about that. Just strike that last comment then. Sorry about that.
Okay, if I may, Scott Fleur, Cisco Systems, I have a separate question. If we're actually using two different signature algorithms, what do they both actually sign? Do they sign the same value independently, or do you pre-hash that as a hash whatever you're signing, and then both algorithms actually sign the hash?
So it's a little bit up to the signer. So generally speaking, if you build two signatures that are identical, they won't have the same hash because they will have two different algorithm IDs anyway. So the crypto part does not sign the same hash. PGP has a hashed and signed paradigm. So we basically put in some we put in the data, we put in then some, how to say, some packets, some sub packets hashed as well, saying, well, this is a signature version 15, and it has been done with algorithm 128, and it has been created at this time, it will expire, etc., etc., etc. And then all of this gets hashed, and then this gets cryptographically signed, the
Okay,
hash.
thank you.
I may have misunderstood, but I thought that maybe the question was about the two algorithms in the composite algorithms, or no? Because
Scott, yeah.
yeah, I assume the question was like if we sign a message using a composite algorithm, like what do we sign, like with both of those algorithms, right? And I assume the answer is right.
Scott, can you come to the mic and clarify?
Okay, I would remind you that I am basically ignorant of how PGP works internally. I was more on a general question that if you take a look at, say, how MLDSA works, it actually internally logically prepends a fixed value to the messages being signed, hashes that, and then does its computation. If you do that along with ED 25519, that does not do that. And so if you're signing along messages, pre-hashing, having both sign a common hash makes a lot of sense. Now, if it doesn't apply to PGP, that query is irrelevant.
So I think that in this case, the option 1 would sign a different hash, while instead option 3 would sign the same hash.
Okay.
So, and also this is, as of now, as we were speaking, the signatures are for now bound to version 6. So the PQ algorithm are bound to version 6 signatures that also prepend a random sort at the beginning, already at the OpenPGP level. So that security advantage that, for instance, SLHDSA has is not, it's extended to all the algorithms, even RSA technically.
Okay. Thank you.
Yeah.
And entirely unrelated to that, but at the risk of re-questioning whether we really need 3 variants of SLH DSA, I understood one being a potential replacement for MLDSA, but then is there any chance that for code signing, for example, we could manage to agree on one of the other two? Or is there anybody in the room who wants to do code signing and wants to speak to the need for having both? Or have you heard from them? Or yeah.
I can briefly recap the discussion we had on internally within the authors, and Andreas at least seemed to be quite keen on to having both of them. And the reason is the fact that there is a significant size difference between the two. And so forcing everyone to have the highest security one, because if we should force the highest security one probably, might require then every signature to be something like 50K and every key to be somewhere around 150 to 100K. So that's quite large.
Yeah, I guess my only point would be, since we already have 2 security levels of MLDSA, I'm not sure if we then also need 2 security levels of SLH DSA, since in my mind, it's kind of already a fallback in case MLDSA turns out to be insecure, or unless you need something with very high confidence that can, stay secure for a very long time frame. But it's kind of a fallback of a fallback, right? So to me, it seems strange to have 3 variants of it. But again, I don't think it matters that much. I'm not that concerned about, code points or anything like that. So, but yeah, that's all.
Minor correction. I believe 256S is actually something like 25K or so, not 50K.
You're right. Yes, the 50K is the F version. I was wrong.
Yeah, I would just point out too that the SLDH8, even the smallest one there, still is about 8K, which is still smaller than the MLDSA plus ED 25519. So I think having a smallish one that for people that are they want that security, but don't want massive huge is good. And then like you already have the 256, which isn't the largest one, so that's probably a good compromise. Maybe the middle one is if you wanted to reduce it. Like I agree, probably someone wants the higher security one, right? If you're paranoid and you want that security and you don't care about size, and then if you want something maybe that's at least comparable to like the MLDSA 87 size with ED4, actually that's still quite a bit smaller. So I'm just saying you probably could reduce one of them if you wanted to make it smaller, but what you have there, if it gives, I think this is going to be a night like the 8, 17, and 25 or something like that. So it's probably, it gives people choice, right? So I guess if you're concerned about conserving code points, then maybe you want to remove one. That's all.
So very briefly, the reason why we decided to go with all 3 of them is because we couldn't pick 2 out of 3. We weren't just simply agreeing on which 2 to give. And I think at least for an experimental rollout right now, these are not a crazy amount, and we should be able to how to say to if we then want to weed something out, we can also do it later.
Mike Ainsworth. So thinking out loud here, I know it's clear to Andreas when you would use each of those 3. Do you think you could write that clearly enough in a draft that it becomes clear to implementers or end users when each of those is appropriate?
I will reply yes to implementers. To end users, I don't know. If I looked at how I used to pick algorithms when I was 15, I was like, oh, look, Brainpool. That looks a nice name. So it's like, no.
Yeah, so I guess I submit that as a potential way to choose here. If we think we can describe clearly enough the differences, then it makes sense to have 3. If we can't, then maybe it doesn't.
Okay. So I guess the bulk of the presentation was about 3 options. Option 2 doesn't seem to have any fans. I guess that's fair to say. Nobody seems to be standing up and saying they like that option 2. The authors clearly prefer essentially option 3, and that clearly has a bunch of support. There's probably a bunch of transition issues, which we'll have the next presentation on as well, that would affect how that would play out. So it kind of looks, even though I prefer option 1, just to, my personal opinion is pretty clear, I think. But it looks like the working group is turning towards getting implementation experience with option 3 modulo figuring out transitions. Does that sound about right to people? I don't see anybody disagreeing. So I think that's kind of where we're going forward with, for now at least, is essentially with what's, I guess, with the hybrid 2 code points and then some SL HDSA code points to try and get some implementation experience with those. DKG?
We have 2 more slides left in the slide deck. Should we run through that and then maybe run a poll to ask if people are okay with the alter proposal as a next step?
Sure.
So this slide is what I just said, is just adding the cute name of suspenders, wearing both belt and suspenders for now that you came up with, DKG, for option 3, at least with MLDSA, because this solution is still option 1 for SLHDSA and option 3 for MLDSA. So we've done also the hybrid between the options. We brought it to the meta hybrid. And then, well, this quote also from DKG. Thanks everyone for the vigorous discussion that he sent at the last, or one among the last emails that were on the mailing list. Well, it has been tough to review all of this. I hope I didn't miss anyone. I hope I didn't misinterpret anyone's opinion. And yeah, let's probably hold a poll if this can be a provisional solution forward towards looking for consensus.
So if you want to go back a couple of slides to the altered thing, and I can ask a poll saying, are people okay with proceeding on this basis for now? Is that
Just
okay?
to clarify, are we asking about the alter proposal for signatures or all of the alter proposals that have come previously in the slide deck as well?
Good question. And how about we go for the bigger scope and one poll,
And then,
if we get it?
Yes, let's do that.
Okay, so I'm going to start a poll that says, are people okay with proceeding on this basis for now? Which means what we discussed about chems and combiners and signatures, with the knowledge that things may change as we get implementation experience, or as CF4G produces a massively great combiner, or as transition schemes indicate that some ideas about hybrids or non-hybrids are right or wrong. So there's the poll. If you think, if you're okay with the plan forward as discussed today, then please click yes. If you think there's something wrong with that, then please click no. And if you have no opinion, then either click that or don't click that. So, and we have 45 people in the room, so there's about a dozen or so have clicked something so far. So we give it a minute. And it seems to have stopped at 10 people okay and 5 with no opinion. So that's, it's not overwhelming in terms of the number of people in the room, but then it's the time zone issues are, again, some people participating and so on. So we got a few more.
If you want to see it again, here's the alter proposal for chems. And
this is for all. Yeah. He's just flicking through them. Yeah.
Yeah, exactly. And the alter proposal for the key combiner.
Okay, so I think it stopped at 16 yes, 9 no opinions, 0 no's.
I really appreciate all the no opinions showing up here for the poll. It's good to know that you're awake.
Yes. Okay, and then again, as always, that'll be confirmed on the list. And but I think there's a path forward for to get some more implementation and interoperability experience. That's good. Okay, so we'll terminate that poll. Thanks, Aaron, especially for trying to summarize all of that discussion from the list. I think you did a good job of it. Thank you. And
thanks everyone for participating into this discussion.
Okay, and I think next up is Justice to so Justice, I can start sharing the slides and give them to you then, I think, or can I? Let me
No,
see.
I'm happy to have you drive the slides. I only have 3.
Sure, I'll do that.
So I'm bringing 2 questions that came up during the interim meeting that we had. Next slide, please. My first question is, the current draft binds signatures to v6 keys, meaning that only version 6 certificates may have PQ signing subkeys, and you can't have a v4 certificate or v4 PQ signing subkey. But it does not do the same for encryption subkeys. And the question is simply, should it? And the argument that has been brought forward for not doing the binding is that we don't want to impede the adoption of post-quantum encryption because we need to get that out early. And next slide, please. I think we should do bind post-quantum encryption to version 6. I think this will make messaging a lot easier. You know, if you're supporting v6 or if you're supporting post-quantum, we know exactly what that means. And I don't get the argument that version 6 support will impede the switch to post-quantum algorithms, because this will be mandated by the BSI, by NIST, so people have an incentive to do that anyway, and we may want to make that an incentive to switch to v6. And the last point that I have is that according to my tests, adding a post-quantum encryption subkey to a v4 certificate will bring a lot of problems in the current ecosystem. So I don't think that's a viable thing to do currently. All right, I want to give it back to the room, or
Justus, can you
gather
just
some feedback.
before the queue starts, can you explain what this test is showing specifically?
All right, so the test shows a version 4 certificate, and I have added, you know, in the top row you see that that's the base case. It works everywhere, and then I'm
But
adding.
What works, Justus? What is
Okay.
the test?
All right, so I'm trying to encrypt a message to this certificate with every implementation that I test. And then in the subsequent rows, I add an unknown encryption subkey. And there are various ways in which they can be unknown. It can simply use
So the certificate retains its classical encryption capable subkey.
Oh yeah,
and you're
it
just
does.
adding a new subkey.
Indeed.
Just to clarify what the transition vision is here.
Yeah, thank you. So I'm trying to model a way to upgrade to post-quantum encryption in an opportunistic way by adding a post-quantum encryption subkey. And there are various ways in which the algorithm is unknown, or there is a non-MPI encoding as a non-traditional encoding, and the key can be small or big, or it may simply use an unknown curve with ECDSA. And you can see that a lot of implementations that are widely used don't work well or don't react well to unknown algorithms. So I believe this will improve greatly with version 6, because in the crypto refresh document, we have wording saying, you know, if you do encounter unknown artifacts that you don't understand, but you can still proceed, do proceed.
Okay, and so Justice, you had another slide. I don't know if you want to talk to that before we drain the queue, or?
Well, okay, that's like a different. I think this is orthogonal.
Okay, so let's take the questions on this one then. So Falco.
Yeah, hi. Falco Strenske, MTG. Yeah, so this I can say something to RMP. So I mean, it doesn't look good here, but RMP actually implements a flag that you can use to enable the digestion of unknown algorithms. And so this might be repairable in applications without RMP, without changes to RMP. So for instance, Thunderbird is of course one main application, one main email client that uses RMP, and Thunderbird can fix this without RMP changing by just making different API calls. Just one detail to point out here.
Thank you.
Rich.
Rich Salzakamai, I point out that the TLS group adopted a draft that found it useful to state that post-quantum will not happen in TLS 1.2. And it's kind of like your second bullet there. So yeah, I would suggest making it a V6 only thing.
Aaron?
Yeah, so, I mean, brief response to Rich is the fact that we don't have the luxury of having real-time kind of negotiation. We scream out a key to the web, upload it to some key server, and then hope that the other people will understand it and will use it. And so I don't think we have the same constraints there. But what I think that of this line is very important is actually the third line. So the third certificate, the unknown algo opaque encoding small. That's probably the classics, the scenario where you take a key, an existing v4 key, and attach to it a subkey that is ED25519 plus MLChem, what is it, 768 subkey. And that, I mean, I know that at least at Proton we're upgrading OpenPGP. Our applications to use only OpenPGP 3.0. We're working on that. RNP has the flag. PGP has also the corrected build from DKG. I just hope that some implementers, that some people that had expressed uncertainty about moving to V6, or are not like, or some users like me that would just like to add this and make sure that there's also their V4 certificate on top of their V6 is PQ capable. I think it's a reasonable option to just add it and hope that it doesn't break too much. If it breaks too much, I would be happy to have these other people breaking and being like, oh, maybe I should update.
Rich Sauls again. The decision in the TLS group wasn't about online real-time version negotiation. It was about encouraging people to upgrade their software stacks. So that was, yeah, and I think that applies here too, which is what I think you were suggesting, Justice.
Staying in the queue because I would also like to reply to this. And I think that's also the point of V6 signatures. V6 signatures, if you want to have a fully PQ key, you need to have V6. And you need to upgrade, and it makes no sense to make a V4 signature in my opinion, because anyway, if you want PQ, you'll understand V6. And if not, you can't even parse the certificate at all. So that's my point of view. But for at least for encryption, hoping that someone will understand PQ and V4, maybe.
So I think there were voices on the list trying to argue to include binding post-quantum encryption into v4. I guess those people are not at the session today, remotely or physically. But it seems like people are generally agreeing with Justice's proposal here today. I'm not sure. Daniel?
So I just wanted to clarify that there's a question about v4 certificates, and then there's a question about what kind of encryption is actually being made. And certificates sort of sit on their own, and I think this is what Eustace's last slide is about, actually, so maybe we should move to that. I don't know how orthogonal it actually is. But there is this issue that we are expected to send encrypted messages to multiple recipients, and not every recipient will have the same characteristics. So maybe you want to talk on this slide?
Right. So we talked about how to transition to v6, and we agreed that it's important to be able to encrypt a single message to a v4 and v6 recipient. And this question comes up again in the context of PQ. Imagine you're encrypting a message to a classical ECC recipient encryption subkey and a PQ encryption subkey. Should that work? Should that not work? I think this is the more important question. And then there's the related question of what kind of encryption container should we use. So the classical v4 version is the CypD version 1, which is this weird authenticated encryption mode specific to OpenPGP, or CypD version 2, which does proper authenticated encryption. But I think we should first think about the more general question.
So I'm going to do this from the queue, not from my capacity as chair. If we say that it can fail to encrypt a message, if you can encrypt a message to recipient A who has only classical, and you can encrypt a message to recipient B who has only post-quantum, and we say that you cannot encrypt the same message to both A and B, that is a novel failure mode for OpenPGP. We currently say if I can encrypt to X and I can encrypt to Y, there is a way, like, I can encrypt to both X and Y. And if we say suddenly that there's some way for there to be an A and a B that you simply cannot encrypt to, that's a novel failure mode. Do we want to introduce a novel failure mode? Maybe it's appropriate. But it does seem like, for example, I would be interested in thinking through what that failure mode looks like in terms of SOP. Should we have a different error message in SOP if there's an attempt to encrypt to two incompatible keys? Or how should that be handled? So I just want to observe that there's a wrinkle there.
Aaron, putting my user hat on, I think forbidding is extremely user hostile. So like to the point of we need to send two different emails and I can't put people in carbon copy or whatever. And anyway, I'm gonna send that email not post-quantum encrypted because I don't have a post-quantum key for that recipient. And I want to communicate to that person. So as much as I also think that the SIPD v1 with the silly SHA-1 system maybe is not the bestest practice, but I still consider it safe. So it's not the like tag 9 kind of encryption. So I would personally think that as much as there might be a discussion whether to allow encryption, whether to allow v4PQ certificates, that's a fair point to say, okay, we want to push people towards v6. We cannot say, okay, now you have a v6 certificate, well, you can't communicate, v6 PQ, you can't communicate anymore with the v4 people. Like you can't be put in the same group as the v4 ECC people. So I think that this question for me is a hard, we should not fail, that should work, and we should use SIPD v1.
I think I agree. We should allow that and not fail. So should we vote? What's the
Well, I mean, we can run a poll if that would be useful. But so if everyone has agreed, and so far there's only been a few voices, but if people are willing to agree that it is okay to do SEIPD v1 to a post-quantum key, then the way that the protocol artifacts are, you could generate a certificate that has a v6 v6 subkey, right? That you could put a v6 subkey in a v4, attach it to a v4 primary key. That's doable.
I don't think it is.
You don't think it's possible to put a v6 subkey on a v4 primary key? I mean, I can place the packets in order.
Oh, you can, but I think we restricted v6 keys, v6 subkeys to v6 certificates in the crypto refresh.
Okay.
I think.
I didn't remember that, so sorry about that. So the argument then is, okay, so then the question is, if I make a v4 subkey and I choose one of these post-quantum algorithms, what should the recipients do if they see a v4 subkey that has a post-quantum algorithm?
Sorry, DKG, I didn't get, can you repeat what you said there? It sounded something wrong to me.
So it sounded to me like what Justus is saying is that the post-quantum algorithms should be marked as only acceptable in a v6 encryption algorithms. So the post-quantum signature algorithms are already marked in the draft as only being acceptable in v6 keys.
Mm-hmm.
And there's a question of, should the post-quantum encryption algorithms also be marked as only acceptable in v6 keys?
Sure.
And so my question is, if someone produces a public key packet that has one of these algorithms in it, what do we expect implementations to do with that? Just reject it?
What we do with v6 signature, v4 signature keys, we throw an error when trying to generate, and we just reject consider a key invalid when parsing it.
And would you be willing to do, if the consensus of the working group was that the same is true for encryption keys, would you be willing to reject it on input?
If you make it a must, like v6 keys and not a should, I would be into say OpenPGP does this, or yeah. I mean, if it's just an invalid key, is it much as I write versions 15? It's a key that I don't understand.
Okay, so to try and summarize, I think on slide 4 here, if I'm correct, I think people in asking the first question is, if I want to encrypt a message to a classic recipient and a post-quantum recipient, I think people were saying that yes, you should go ahead and do that, even though you won't. Obviously, you're emitting text you're emitting ciphertext that is, vulnerable to a cryptographically relevant quantum computer, but we want the messaging to work. So I think the answer to the should that work was yes. Is anybody going to disagree with that, or is that's the right summary? And then the not quite orthogonal question about V4 and V6. I thought but I'm not entirely sure, but I thought I was hearing that people were happy with the idea that you must use V6 for post-quantum everything. Does anybody want to disagree with that? Please do. Aaron?
I would prefer the V4 keys to be able, and I think also, I mean, he's not here, Kai expressed a strong preference in this direction.
Yes, that's correct. Okay, Paul?
Paul Wouters, speaking just as an individual. There's a bit of a subtle difference between saying not V4 or like V6 and higher, because there's this like V5 number in between that has effects if we make statements or sort of implicitly not support V5 in there. So I'm not sure if that's what we need to do here, but like,
sure,
there is a difference between saying not V4 and saying V6 only. So I think if you want to avoid that in this question, maybe just say not V4.
Yeah, okay. Aaron?
Please don't put PQC and V5 in the same sentence. They are really trying to implement something completely different, reusing the same algorithm IDs.
Okay, so
I think either we do V6, we bind it, or we say like V4 or higher. I don't know, because V3 I would exclude it hard, but I think that already crypto refresh does that. Like,
sorry,
you can't generate V3 keys anymore.
Sorry, Paul again. I'm not saying we should make any statements on V5. I'm just wanting to make sure that I would like us to not speak about V5 and sort of not interact with it. So only saying like we don't want to do this for V4, like, because that's really what I think that the question here is: do we want to do this on V4 and V6, or do we only want to do this V6? And so like sort of avoid V5. It's not our thing. It's a code point we skipped. We don't have to worry about it.
Sure,
but don't make a statement about it.
So fair point. So I guess then the what people in the room and online at this session seem to be agreed upon for now is that the post-quantum mechanisms we're defining will be defined for V6 and higher, but not for anything not V6 and higher. But we know that there is some opposition to that position from some people who are not present at the session. So again, that sounds like something we should explicitly start a thread on the list about and try to bottom out on that. Is that a fair summary? If it is, I don't think we need a poll because there's. Okay, so that seems to be that's where the meeting is at, and we know that there's a counter argument to come on the mailing list when we raise the thread. DKG?
Yeah, so I just wanted to observe the time. We are almost out of time for the session. We did not get to any other business, and we did not get to the questions about the other things that we talked about as a working group being milestones. So I'm going to follow up on the list to try to raise the potentially next draft adoption things. Daniel, I know that you had slides to present about persistent symmetric keys, and I hope that folks will look at those slides. I will point to them in the mail that I sent to the list. And Andrew Gallagher also had a pointer to the replacement key draft that he and Daphne Shaw were working on. I will point to those too. So I just wanted to give people a heads up on that. We do need to be thinking about that because those milestones are ostensibly for this month. So just a heads up.
Yep, and I guess then also yeah, we'll do the usual sending the minutes to the list as well. I suspect it's likely that we'll want to organize an interim meeting. We'll discuss on the list the timing of that, but maybe April-ish. It might make sense to have an interim to see how we're going forward on the post-quantum stuff, and then maybe also have more of a chance to think about adoption of other items. I think, yeah, we're out of time. Thanks everybody for playing along. I think we made some progress, and that's good. And let's keep doing it on the list. Thanks all.
Thank you.
Bye. Thank you.
Bye-bye.
Bye-bye.
Stephen. Stephen.
Yes.
Oh yeah, I wanted to ask you whether I should follow up on the list and with the next thread being the binding to v4.
Sorry, say again.
If I should follow up on the list with the next thread being binding to v4.
Oh, sure. I mean, yeah, maybe wait till we post the minutes and then do that. Yeah.
Yeah, not tonight. I'll now go to bed. It's 2 a.m. here. So,
I hope you mean binding to v6.
Sleep well.
Yeah,
and,
sorry,
bind to v6. Yeah.
Exactly. Binding
sleep
to
well.
v6. Exactly. It's 2 a.m.
Yeah. Sleep well. Thanks for staying up late.
Thanks. Ciao.
Bye-bye.
Tell her that Wednesday's great.
Okay. I was quite tempted to accept your Acme slides. So what was that? It was just a data tracker. Is it easily confusable? I haven't seen that happen before.
When I have multiple sets of materials up in different tabs.
Yeah.